Okay, well, the next thing we need to talk about, and that'll probably be in the next class, is magnetic field interactions and circuits. And there are only three things good, you need to know about that. That the contribution to the magnetic field of a current through a short, straight increment of a current carrier is calculated by this law. You do the I delta L multiplied by the R vector divided by its magnitude divided by R squared and multiplied by K prime proportionality constant. It's an inverse square law with the IDL and the R and so forth. Very much analogous to the way you'd calculate an electric field, but you got this cross product in here which complicates the picture a little bit and makes you have to use your right hand a lot. Alternatively, instead of I delta L, you can use QV, QV being completely equivalent to an I delta L, QV being charge times its velocity, I delta L being current times distance. And you need to understand, and I recommend that you think about why that would be a quantity that's commensurate with this one. Units are easy, but you want to think a little more deeply than units too, although thinking of units is a great start. That's deep enough for a lot of people. The force on a moving charge is QV cross V, the force on a moving charge due to a magnetic field. So what magnetic fields come from moving charges, either as currents in conductors or as isolated moving charges in space. And magnetic fields act on moving charges. It's kind of a neat little circular, it's not exactly a circular argument at all, but a little circular set of phenomena, and I'm not using good words. Okay, so we have that, and that leads to certain types of circuit elements. There are three basic types of circuit elements: resistors, inductors, and capacitors. Capacitors behave in the way we've seen, and here's an example of a capacitor. Next time we'll find an example of an inductor, a coil of wires that creates a magnetic field, and when you change the current, the magnetic field changes, and that creates a voltage that tends to fight the change in the whatever's creating the current. And then you got Ohm's law, voltage equals current times resistance, something we have a pretty good grasp of. We put these three things together, and voila, we get the magic of the LRC circuit, which is a very neat thing and very much worth understanding.